In this question, it is given that let the equation of the plane passing through the line this and parallel to the line this be ax plus by plus cz equal to 65. Then the distance of the point ABC from the plane this is dash. You have to fill in the blank. First we find the equation of plane, as it is given that there is a plane passing through this line. If you don't know, remember that there are two forms of equation of line in 3D. One is symmetrical form, that is x minus x1 upon L, y minus y1 upon M, z minus z1 upon N. This form of equation of line is called symmetrical form, where x1, y1, z1 are coordinates of a point lying on the line and LMN are direction cosines of this line. You must have studied this thing in 12th class. But let me tell you this thing also, that the two planes, namely A1x plus B1y plus C1z plus D1 equal 0 and A2x plus B2y plus C2z plus D2 equal 0. A line is represented by two planes also. Actually, how two planes represent a line? See, suppose one plane is this, other plane is this. Those points which satisfy this equation also and this equation also, they will be lying on this line. That is, I can say two planes simultaneously represent a line. That is, those points whose coordinates satisfy this equation also and this equation also, those points lie along a line, and that line is the line of intersection of these two planes. Hence, the plane which contains this line, that plane can be taken as passing through the line of intersection of two planes, because the plane which is containing this line can be taken as a plane passing through the intersection of these two planes. Therefore, the equation of this plane will be one plane plus lambda times the other plane. Hence, the equation of plane which is passing through the line this, equation of that plane will be one plane plus lambda times the other plane. That is x minus 2y minus z minus 5 plus lambda into x plus y plus 3z minus 5 equal to 0. And further it is given that this plane is parallel to this line, that is the line of intersection of these two planes. Suppose this plane and this plane are being represented by this, and this is the line of intersection. That is, these two planes are representing this line, and this plane and this plane which have this line of intersection, that line will be parallel to this line. This line of intersection of this plane and this plane, that is this line and this line and this line, will be parallel to each other. That is, I can say this line and this line, because these lines are parallel, these three planes are forming this type of prism, P1, P2 and this plane. This plane and this plane are forming the prism. That is, this plane and this plane are forming a prism. And you must know that the equation of three planes A1x plus B1y plus C1z plus D1 equal 0 A2x plus B2y plus C2z plus D2 equal 0, A3x plus B3y plus these three planes will form a prism. D is equal to 0, and out of D1, D2, D3, at least one is non-zero. I mean to say the three equations have no solution. And geometrically, if D is equal to 0, D1, D2, D3 all are 0. That is the situation. This plane, and the plane this, which is passing through the line of intersection of these two planes. The three planes are intersecting along a line, and these points are lying on this plane also, and this plane also. That is, I can say there are infinite number of points which satisfy this plane also, and this plane also. That is why if D equal 0, D1, D2, D3 all are 0, it means the three planes are intersecting along a line. And if D is equal to 0, out of D1, D2, D3, at least one is non-zero. That is a situation of no solution. And no solution is there when one plane is this, second plane is this, and third plane is this. That is, there is no point which will lie on all the three planes. Therefore, if D equal to 0 and D1, D2, D3, at least one of them is non-zero, then there is the case of no solution. That is, no solution means this plane, and this plane are forming a prism. When D is non-zero, that is the situation of unique solution. Unique solution means there is only one point which will lie on all the three planes, and that will happen when one plane is of this type, second plane is of this type, and third plane is of this type, and this is the only point which lies in all the three planes. Hence, if D is non-zero, there will be only one point which will lie in all the three planes. And because presently I told that these three planes are forming a prism, therefore for forming a prism, the condition is D is 0 and at least one of them is non-zero. We'll be using this to find the value of lambda, and once lambda is found, you'll be getting this plane, and this plane is given to us as ax plus by plus cz equal to 65, and comparing this plane with this plane, we'll get the value of ABC. And once ABC are found, then distance of this point from this plane is very easy to find. And because this can be written as x into 1 plus lambda plus y into minus 2 plus lambda plus z into minus 1 plus 3 lambda minus 5 lambda equal to 0. Now this plane x plus y plus 2z minus 7 equal to 0, and 2x plus 3y plus z minus 2 equal to 0 are forming a prism. Prism means D is equal to 0 and at least one of D1, D2, D3 is non-zero. Actually, in examination, we don't have time. Therefore, the point to be noted is using D equal to 0, I can find the value of lambda. I need not check the value of D1, D2, D3 because it is sure that out of D1, D2, D3, at least one will be surely non-zero. If all are zero, infinite number of solutions will be there. If infinite number of solutions are there, then the question will become wrong. And this implies that 1 plus lambda minus 2 plus lambda minus 1 plus 3 lambda. 1 1 2 2 3 1. This should be 0. And now use the property that C2 changes to C2 minus C1 and C3 changes to C3 minus 2C1, and I will be getting 1 plus lambda 1 2 0 1 minus 3 lambda minus 1 minus 2 0 and minus 3 equal to 0. This implies that 9 minus lambda minus 3 equal to 0. That is, it means lambda is equal to 12. And out of D1, D2, D3, it is sure that at least one of them will be surely non-zero. This I know beforehand. Still, for the clarity, I am showing it. D1 is equal to, you must be knowing, it is 5 plus 5 lambda 7 2 minus 2 1 3 minus 1 plus 3 lambda 2 1, and because lambda is 12, this becomes equal to 65 10 35 7 2 1 3 2 1. That is 5 common. 13 2 7 7 1 2 2 3 1. Just by looking at this determinant and doing minor calculation in mind, it is easy to say that the answer is going to be non-zero. Yes, if I have to find the value of determinant, then I will have to evaluate it. But if I just want to check that it is going to be 0 or non-zero, for that it can be checked just in mind, doing only minor calculations. How, the detail of this I have told in the lecture of determinants of JEE level. And now putting lambda equal to 12 in this, I get the equation of plane as 13x plus 10y plus 35z minus 65 equal to 0. And because this was the equation of plane which was parallel to this line, hence this is same as this plane. Therefore, A equal to 13, B equal to 10, C equal to 35. Now the distance of the point ABC, that is 13, 10, 35 from this plane, say it is L, will be equal to mod of 2 into 13 plus 2 into 10 minus 35 plus 16 upon under root 4 plus 4 plus 1. That is, L is equal to 26 plus 20 minus 35 plus 16 upon 3. This is equal to 27 by 3, that is 9. Hence, answer to this question is